Hello, everyone. Welcome back. This is the final video of Lecture 5, so congrats on making it to the final video of another lecture. In this lecture, we're going to actually walk through an example of how a monopoly acts in the case of a market, solve for an equilibrium, and think about some of the implications in terms of efficiency. And so before we jump into that example, I want to talk about market failure and how market failure is related to the case of a monopolistic market. So if we remember back to our welfare lecture in lecture 3, we determined that the welfare in a market is the consumer surplus plus the producer surplus. That's the total market surplus in a market. And remember, we maximize the efficiency of a market. We maximize the welfare obtained in a market um, by solving for the equilibrium where price is equal to marginal cost, right? Because at that point, that's where we have the maximum consumer surplus, we have the maximum producer surplus, and we show that if we deviate, just to the right of that equilibrium or just to the left of that equilibrium, that we don't obtain increases in welfare, and so our optimal welfare solution is where price is equal to marginal cost. But here in the case of monopoly, right, our equilibrium solution is not where price is equal to marginal cost, right? We showed that the equilibrium solution is where price is greater than the marginal cost. And so that resulted in a lower quantity produced in a monopolistic market than in the competitive market. And as a result of this, there are some important welfare implications. And in particular, the welfare is going to be lower in a monopolistic market than a competitive market, sort of holding all the other stuff equal, because of the fact that the equilibrium outcome is not where price is equal to marginal cost. Okay, and in the context of economics, we call this sort of loss and potential surplus dead weight loss, and this is something that we'll hopefully have talked about in lecture in the synchronous lecture 3 discussion. But in case we haven't gotten there, or you're watching this video before that discussion, just really quickly, deadweight loss refers to the loss and potential surplus due to a market failure. And we'll show it below graphically, but that's the intuition behind what deadweight loss is. It's basically what's the welfare we could have obtained had we been operating at the efficient equilibrium solution. Okay. So with that setup in mind, let's jump into an example talking about monopolies and this concept of deadweight loss. Okay, and so suppose a monopolist faces a demand curve, a market demand curve, right? That's P equals 24 minus Q, and has a cost function, right, for the specific firm itself as the monopoly as C of Q equal to Q squared. Okay, so what I want to do is graphically determine both the competitive equilibrium and the monopolist equilibrium, and then talk about some of the welfare implications of each of these equilibria. Okay, so we know the competitive equilibrium is where price is equal to marginal cost, right? And then the monopolist equilibrium is where marginal revenue is equal to marginal cost, right? And we talked about why those two things are different in the case of a competitive and monopolistic market. Okay, so let's go ahead and first graph this market. Okay, so I have P here, I have Q here. My demand curve is 24 minus Q, so I know that my y-intercept is 24. My x-intercept is also 24 because it's just 24 minus Q. My cost function is C of Q equal to Q squared, which means what for my marginal cost, right? My marginal cost is equal to 2Q, right? Just the derivative of that, okay? So marginal revenue or marginal cost is just this upward sloping curve starting from the intercept because we don't, this is like a plus 0 here. And this is our marginal cost, okay? And so here's our competitive equilibrium. And we can solve for that numerically, right, by setting our price function equal to our marginal cost, right? So for competitive, P equals MC, which implies that we have 24 minus Q is equal to 2Q, right? So we get 3Q equals 24. Q for the competitive is equal to 8, okay? If we plug in 8 back to either our marginal cost or our demand functions, right, we get P for competitive is equal to 16, right? Okay. So that's the case, that's the equilibrium condition for a competitive market. How about for a monopoly, right? So for monopoly, we need to introduce one additional curve to our graph, which we haven't yet, which is the marginal revenue curve. And how do we get the marginal revenue curve? Well, we know that revenue as a function of quantity is equal to P of Q times Q, right? Well, we've been given P of Q, which is just our demand function, right? It's our price function. So this is equal to 24 minus Q times Q, right? If I multiply that through, I get 24Q minus Q squared. And so what's marginal revenue? It's just the derivative of the revenue function. So marginal revenue is equal to 24 minus 2Q, okay? And you'll notice that the marginal revenue has the same intercept as the demand curve, but the slope is just 2 times as steep. And that's always going to be the case when you have a linear demand curve. That's just a special property of a linear demand curve, that the marginal revenue curve has the same y-intercept, but it's just 2 times as steep. Okay, so we know marginal revenue is going to look something like this with an intercept of 12, right? Because it's twice as steep as the demand curve. Okay, and so we know for a monopoly, our optimal quantity produced in the market is where marginal revenue is equal to marginal cost. Okay, so that's this quantity, and we know that the price is going to be such that at this quantity we draw up to the demand curve. Okay, so now we can solve for each of these points. Okay, so first let's solve for the quantity for the monopoly. Okay, the quantity for the monopoly, I'm going to draw on this side, is marginal revenue equal marginal cost, which implies that we have 24 minus 2Q, because that's our marginal revenue curve, is equal to marginal cost. So now we have 24 is equal to 4Q, and so Q for the monopoly is equal to 6. Okay, so that checks out because the quantity from the monopoly is less than the quantity under the competitive. And now what do I need to do with that 6? I don't plug that 6 back into the marginal revenue and the marginal cost. I need to plug that 6 back into our demand curve because this is the point that I want to solve for in terms of the market price. Okay, so I plug in 6 back into 24 minus Q, then I get a market price of 18, which is higher than the competitive, which also checks out. So that's good. Okay, and so now we've solved for the equilibrium points of the of these two different market structures, but we haven't talked about welfare yet. Okay, and so but what you can see here, right, is in the case of the monopoly, price is higher than marginal cost, right? And so we have this sort of region of this triangle here, right? We have this triangle here where there are people that are demanding, right, on the demand curve, they're willing to pay higher than the marginal cost, right? Which we showed in our welfare lecture that if that a point of equilibrium where demand is higher than marginal cost is inefficient because we're preventing people who are willing to pay more than the producers willing to sell from engaging in these transactions, and we're losing that potential welfare. So we call this area the deadweight loss because it's the loss associated with an inefficient equilibrium outcome associated with the monopolistic market structure. So let's show this mathematically. Let's actually calculate the surplus for each of the different markets. Let's calculate the total welfare for the competitive and the total welfare for the monopoly, and we'll show that the monopoly's welfare is going to be lower by an amount equal to the area of this triangle here. Okay, so let's start with competition. So welfare for each of these markets is composed of consumer surplus plus producer surplus. So for competition, how do we find the consumer surplus? Well, it's the area under the demand curve, right, up until the price in the market, right? So our graph is going to get a little bit colorful here, but our consumer surplus is the area under the demand curve, right? So up until the market clearing price, up until the equilibrium quantity and above the market clearing price. So it's the triangle outlined by this green shading, okay? And so the dimensions of this triangle, we have 8 on the y-axis and 8 on the x-axis. So consumer surplus is going to be equal to 0.5 times 8 for our height times 8 for our base, which is equal to 32. okay? And for producer surplus, similarly, right, it's just the area above the supply curve up until the market clearing price, stopping at the market equilibrium quantity, right? So it's just this area, okay? The orange shaded triangle. And so that area is going to be our height is 16, and our base is still 8, so it's going to be 0.5 times 16 times 8, which is equal to 64. So our welfare is just the sum of these two terms, so that's equal to 32 plus 64. So we have a welfare of $96 in our competitive market here, okay? How about for the monopoly? Okay, so again, we have a consumer surplus and a producer surplus for the monopoly. Let's take a look. So for the monopoly, right, the market price for the monopoly is 18, okay? It's 18. So the consumer surplus, again, using our definition, is the area under the demand curve, right, up until the market clearing price and stopping at the equilibrium quantity. So the monopoly's consumer surplus is going to be a lot smaller than the competitive one, right? The monopoly consumer surplus is this purple shaded triangle, okay? And that should make intuitive sense, right? Because the monopoly is charging a higher price and lowering the equilibrium quantity, so consumers are going to suffer by the higher prices due to the fact that the monopoly produces less than the competitive market. Okay, so our height here is 6, 24 minus 18, and our base here is also 6. So we have 0.5 times 6 times 6, which is equal to 18, right? Okay. And what's our producer surplus? Well, again, even before we even start this, the intuition should be the producer surplus should be higher for monopoly than for a competitive, because that's the entire idea of why a monopoly would restrict quantity and increase prices in the first place, is so they can make more money. Okay, so the producer surplus is, we'll do this one in yellow, is the area above the supply curve, right? Oh, yellow's a bad one. Let's do this one in brown. The area above the supply curve, right, up until the equilibrium quantity, up until the market clearing price, right? So it's this trapezoid, right? This trapezoid here. Okay, so we need to calculate this. You can either use the formula for a trapezoid, or the way I like to do it is separate it into a rectangle and a triangle. Okay, and so how do we do that? Well, we need to solve, in order to do the rectangle and triangle method, we need to solve for what the y value is for this point, because that's going to form our bottom triangle, and then we'll be left with a rectangle at the top. Okay, so how do we solve for this point? Well, it's the price associated with the marginal cost and marginal revenue curves at the equilibrium quantity. So if I plug in 6, right, 6 to either the marginal cost or the marginal revenue curve, that will give me this y value here, which is a meaningless value from an economic context, but it's important for our area and surplus calculations. So I plug in 6 into my marginal cost curve, which is just 2q, then I know that this value is equal to 12, right? Okay, so now I can calculate the triangle plus the rectangle to get my producer surplus for the monopoly, okay? So how do I calculate the triangle? Well, I know the height of the triangle is 12, 0 to 12, and I know the base is still 6. So I have 0.5 times 12 times 6, plus what's the area of the rectangle? Well, the area of the rectangle is, our height of the rectangle is 18 minus 12, which is 6, right? Just 18 minus 12, which is 6. And our width is also 6. And so we know the area of a rectangle is just height or width times length. So it's just 6 times 6. And so what that's equal to is 72. Okay. So you can see here that the producer surplus for a monopoly is higher than the producer surplus for the competitive, and the consumer surplus for the monopoly is lower than the consumer surplus for the competitive, which again should check out intuitively. And so what's the total welfare for a monopoly? It's just 72 plus 18, which is equal to 90. So you can see the total welfare for a monopoly is lower than the total welfare for a competitive, right? And the difference between those two welfare numbers is exactly the deadweight loss that we graphed here originally in the red shading, right? The difference in welfare is this exact red shading. And I would encourage you to try on your own to prove to yourself that the area of this triangle, right, this deadweight loss triangle is in fact $6, right? That's the welfare loss associated with a monopolistic market structure, okay? So I'll let you leave that as an exercise for yourself. And I hope that this provides some concrete context as to how these two different markets work, how the two different equilibrium work, and what the welfare implications are in this market. In the next set of videos, we're going to move on to our lecture 6, which is going to talk about policies like taxes and subsidies, and an important concept, especially in the context of environmental economics, which is externalities. Okay, I'll see you then.